Assalamu alaikum. My name is Ashar and I am leading presenter of our presentation. The topic of our presentation is biosensor. So first of all, I would like to call Wardah Amir to start this presentation by sharing her part of this presentation. Thank you. Over to Wardah.
Assalamualaikum. My name is Wardah Amir and today my topic of discussion is biosensors. First of all, we talk about when and who made biosensor. Father of biosensor, Leland C. Clark, invented the Clark oxygen electrode, a pivotal device that allows real-time monitoring of patients' blood oxygen levels and has made safer and surgery safer and more successful for millions around the world. Biosensors. These are analyte devices which measure concentration of an analyte. In biosensors, a biological material such as enzyme, antibody, whole cells, nucleic acid that includes DNA and RNA are used to interact with the analyte. This interaction produces a physical or a chemical change, which is detected by the transducer and converted to an electrical signal. This signal is interpreted and converted to an analyte concentration present in the sample. Diagram. As shown in the diagram, analyte interact with biological component and this interaction produces either physical or a chemical change, which is detected by a transducer. This change is converted into electrical signal which is amplified by an amplifier. This amplified signal is then processed by a processor and converted into analyte concentration present in the solution and is displayed on the screen of biosensor. Applications of a good biosensor. Biosensor is used in many fields like in medicines. It is used for the career, cancer and TB and in forensic science and it is used for light detection test and fingerprinting. In environment, it is used for pesticides and aflatoxin. In food industry, it is used for the inhibition of enzymes are used to detect the traces of pesticides that may be present as poisons and harmful residues on farm produce. In medicines, glucose monitoring device biosensors monitors the glucose level in blood interpretation and data analysis performed by a microprocessor. Bacteria in blood platelets, a real-time biosensor, has been developed for detection of bacteria in platelet concentrates. TB breathalyzer. Rapid Biosensor System is a UK-based developed company. Technology for rapid screening of infectious agents analyzes the sample by way of displacement assay utilizing advanced wave and bio-optical sensing technologies. Cancer diagnosis. Different biosensors are available for early lung diagnosis and cancer based on detection of tumor associated antigens and its corresponding antibodies. Environmental monitoring. An optical multi-analyte biosensor has been developed for monitoring of pesticides. A DNazyme-based optical biosensor has been developed for monitoring of heavy metal lead with assay time 20 minutes. A commercialized amperometric microbial biosensor has been developed for monitoring of biological oxygen demand (BOD) in sewage water 15 minutes response time. A SPR-based system has been developed for detection of Bacillus anthracis from soil samples. Food industry. Amperometric biosensor for E. coli 0157H7 has been developed having detection limit 50 cells per ml in 30 minutes by spiking known numbers of cells in milk samples. A fiber optic biosensor has Listeria monocytogenes has been developed with sensitivity 5.4 into 10 to the power 7 CFU per ml in 20 hours. An electrochemical immunosensor for the detection of aflatoxin in food product has been developed with low detection limit. Forensic science. In forensic science, it is used in lie detection test. A polygraph analyzes persons' involuntary psychophysiological responses to questions. The sensors are placed on persons' arm, fingers, abdomen, and chest. The signals produced from sensors detect changes in variables such as breathing, pulse rate, blood pressure, etc., and stored digitally. Properties of a good biosensor. Highly specific for analyte, the response should be linear over broad substrate range. The device should be small and biocompatible. It should be low cost, small, and easy to use. Assay cost should be lower than the conventional test. Assay should be reliable and repeatable.
My topic of presentation is freelancing and its relationship with biosensor. So first of all, we need to get the concept of what freelancing is. So freelancing is a self-employment or a work that you do to get employment. You can do freelancing for anyone, for any website. You just need to have a good grip and good hold on your skills and your intelligence level. Now we will discuss the parts of biosensors along with their working. There are five parts included in the working of biosensors. The first one is bioelement. You need a bioelement that has to be examined. So bioelement is an element that is being scanned. In other words, you can say it as an input unit. And after that, there is a transducer. It is used for signalization. It converts the bioelement, the scanned bioelement, into the form of signals, and then sends it to amplifier. The amplifier is used to amplify. It is used to amplify, and then send it to the processor for the further processing. And in processor, it converts the signals into the readable data for the user, and then it shows the results on the display unit. Now we will talk about importance of biosensors. Biosensors have a powerful impact and are of great importance in our daily life. They are used in almost every field engineering, like blood tests, wastewater treatment, etc. Biosensors are pollution free, environmental free, easily available, recyclable, reusable, and also are inexpensive. If I give you the example of importance of biosensor, if you go for a regular checkup, you need to check blood pressure or sugar level. They use some devices, and these devices are called biosensors.
Assalamualaikum, my name is Mohammed Fawad and today I'm going to present you types of biosensors and tasks performed by biosensors. So there are three types of biosensors. First one is electrochemical biosensor, second one is potentiometric biosensor, and third one is impediometric biosensor. So we'll explain one by one. So first one is electrochemical biosensor. Electrochemical biosensor is a self-contained integrated device which is capable of providing specific quantitative or semi-quantitative analytical information using a biological recognition element. Electrochemical biosensors are used to detect problems in urine by taking samples from the blood. Since electrochemical biosensors provide practically sensitivity and fast response, these systems can be integrated with labs on chips to obtain excellent point of care analytical platforms. Second one is a potentiometric biosensor. A potentiometric biosensor can be defined as a device incorporating biological sensing element connected to an electrochemical potential transducer. Potentiometric biosensor usually rely on a biochemical reaction leading to a simpler chemical species and its subsequent electrochemical detection. Here is the diagram of concentration of glucose of milk using a potentiometric biosensor. Next one is impediometric biosensor. An impediometric biosensor is constructed by immobilizing biological recognition element onto an electrode surface. It reports through measurement and monitoring the targeted analyte through the output of an electrical impedance signal made proportional to the analyte activity. So these are tasks performed by biosensor. First one is common healthcare checking, mainly used in hospitals, clinics, and healthcare centers. Second one is screening for sickness, used for detecting diseases precisely, as we all know. Third one is drug improvement or offense detection, used for preventing overdosing of drugs. And last one is agriculture applications, widely used in veterinary and agriculture stuff also.